On June 3rd, 1998, Germany's Intercity Express, the ICE, wasn't just a train. It was a symbol of incredible engineering, maybe the safest train in the world. But in the span of less than a minute, that pristine reputation was absolutely shattered in a disaster that claimed 101 lives. So, in this explainer, we're going to break down how the simple pursuit of a smoother, more comfortable ride led directly to one of the most horrific high-speed train wrecks in history. Okay, so let's set the scene. It's the morning of June 3rd, 1998. We're on board ICE train 884, traveling from Munich to Hamburg. Now, inside the first coach, a man named Georg Dittmann is sitting with his family. They're just enjoying some coffee, watching the German countryside blur past the window, just a perfectly normal, quiet morning. And then, at 10:42 a.m., with absolutely no warning, bam! Their entire world is just violently torn apart. A jagged, twisted piece of metal erupts through the floor of the carriage, punching a hole right between George's wife and his son. It's a piece of the train's own wheel, and it's the first sign that something catastrophic has just been set in motion. I mean, can you imagine the shock? If that shard of metal had come up just a few inches in either direction, they would have been killed instantly. George, thinking fast, grabs his terrified wife and kids, moves them into the next compartment, and then he sprints off to find the conductor. He has no idea that he just witnessed the very beginning of an unbelievable chain reaction. Now, to really understand what's happening to this train, we need to rewind a little bit. Germany's ICE trains were a huge point of national pride. I mean, they were the absolute pinnacle of high-speed rail. But they had this one tiny, nagging little problem that the engineers were just determined to fix. And that determination would lead them to a truly fatal design choice. So it all comes down to the wheels. The original wheels were what you call monoblock, basically a single solid piece of forged steel. Incredibly strong, super reliable, but they were replaced with this new, resilient wheel. And this thing was way more complex. It had a steel tire on the outside, separated from the inner wheel by a 20mm rubber damper. And all of that was for just one reason: passenger comfort. You see, the thing is, as those solid monoblock wheels traveled thousands and thousands of kilometers, they'd wear down a little unevenly. And at super high speeds, that created these minor vibrations. Now, it wasn't a safety issue at all, but in the fancy dining car, the cutlery would start to rattle against the plates. And for a luxury first-class train, that was just unacceptable. So this new, resilient wheel with its rubber core was designed to completely absorb those vibrations and make the ride perfectly smooth. But here's the problem. In solving that little comfort issue, the engineers created a much, much deadlier one: metal fatigue. Think about it. With every single rotation, that outer steel rim on the new wheel would get slightly compressed as it hit the track, and then it would expand again as it lifted off. It was constantly flexing, over and over, under enormous stress that the old solid wheel just never had to deal with. And the sheer scale of this stress it's just mind-boggling. At cruising speed, every single one of those wheels completed about 500,000 rotations a day. 500,000 cycles of compression and expansion, day in and day out. And with each cycle, microscopic, invisible cracks were starting to form and grow deep inside that. And this is where we get to the really fatal assumption. This resilient wheel design, it wasn't brand new. It was actually used successfully on city trams for years. But here's the kicker. Those trams travel at maybe 30 kilometers per hour? The IC trains were flying along at over 250. The forces and stresses at that speed are exponentially higher. But somehow, the design was approved for high-speed use without any dedicated, rigorous testing for those conditions. It was a colossal oversight. Okay, so let's get back to the train. George Dittmann has found the conductor back in Coach 3, and he's frantically trying to explain what happened. But the conductor, just following protocol, says he has to see the damage for himself before he can stop the train. So as they start heading back towards Coach 1, the train is still barreling along at 200 kilometers per hour, and they have no idea that they are walking straight into the heart of a disaster that is about to unfold in less than 60 seconds. And this is just how terrifyingly fast it all went wrong. First, that metal-fatigued wheel rim, the one that had already shot a piece through the floor, it completely shatters. A piece of it dangles down, catches a track switch, and violently wrenches the rear axle of Coach 3 onto an adjacent track. The train is literally being ripped in half. Coach 3 lurches sideways, slamming directly into the pier of a massive concrete overpass, and that 300-ton bridge just collapses right on top of the coaches coming behind. The momentum of the rest of the train is just immense. The rear carriages just keep coming, slamming into the debris of the bridge and into each other, folding up like an accordion. The force is so extreme, so unbelievable, that 2 entire carriages, coaches 5 and 6, are crushed down to a height of just 6 inches. Everyone inside, killed instantly. Only the first 2 coaches and the front power car, which thankfully broke away, managed to stay on the tracks. The final count was just devastating. 101 people lost their lives. Another 88 were severely injured. The world's safest train had just become the site of Germany's worst rail disaster ever. In the aftermath, a completely stunned nation was demanding answers. How? How could this possibly happen? Well, as investigators started the grim task of sifting through all that twisted metal, a really disturbing picture started to emerge. This wasn't just some freak accident. No, this was the final, terrible result of years of ignored warnings and just systemic negligence. And what they found was just a damning trail of red flags. As early as 1992, a research institute had warned that using this kind of wheel at high speeds could be really dangerous. Just a year before the crash, a tram company actually alerted the National Railway because they were finding fatigue cracks in their wheels. The very wheel that failed on IC 884 had been flagged 8 different times for irregularities. And get this, while crack detection technology existed, inspections were often just done visually with a flashlight because the machines were apparently giving too many false alarms. And this is the most tragic irony of the entire story. That rubber damper, the very thing that was designed to make the ride quiet and smooth, it also masked the signs of its own destruction. A solid steel wheel with a growing crack would have made noise. It would have created vibrations, clear warning signals. But the rubber just absorbed all of that. It effectively silenced the wheel. The wheel was screaming for help, but nobody could hear it. The Eschede disaster was a brutal wake-up call, sending shockwaves through the entire global rail industry. It was this horrific lesson that in high-stakes engineering, even the smallest compromises, the ones made for things like comfort, can have absolutely devastating consequences. The focus had to shift immediately, right back to fundamental safety. And the changes were swift, and they were comprehensive. Within just weeks, the entire IC fleet was recalled and refitted with the old, reliable monoblock wheels. No more resilient wheels. The railway infrastructure was totally reassessed, especially bridges located near track switches. Even the train windows were redesigned. Rescuers had found them almost impossible to break, which had trapped victims inside. And today, the Eschede disaster is a mandatory case study for every new railway engineer in Germany. You know, at the end of the day, maybe the most profound lesson learned was a complete change in philosophy. That rattling cutlery that the engineers worked so hard to get rid of, that wasn't a flaw. It was data. It was the system communicating its state, its wear and tear. In their quest to silence that little noise, they accidentally silenced a crucial safety warning. And so the story of Eschede really leaves us with this huge question, one that applies way beyond just railways. In our constant drive for better, faster, more comfortable, more convenient technology, we have to keep asking ourselves, at what point do we start engineering away the very signals that are designed to keep us safe?